In today's lesson, we learned about function operations and finding their domains. So, operations are addition, subtraction, multiplication, and division. In today's lesson, these three kind of go together, and there's some special rules when using division. Here you can see that for all operations, you can separate out the two functions. So even if it's written as f plus gx, you can rewrite it as f plus gx. Same goes for subtraction and multiplication, and actually for division as well. You can always rewrite these operations as two separate functions and then worry about the operation later. This means that you would solve the function fx, solve the function gx, and then go ahead and either add, subtract, multiply, or divide. When looking for the domain of the sum, difference, or product, you simply combine the domains of each function to create one domain. Most of the time, if there are no fractions involved in either of your functions, so for example, fx equals 2x minus 1 and gx equals x squared plus 2, there's no fractions here at all, and so pretty much all real numbers will always work. So your domain in this case would be all real numbers, which is true for both G and F. For fractions and for division, we have to follow some extra steps. And this is because in a fraction, or when dividing, a denominator can never equal 0. If it equals 0, we have an undefined value, and so it doesn't exist. So whenever we have a fraction, we use this special rule. So in division, we always have a fraction because we create that division sign is our fraction bar. But I'll also show you some examples in a minute of how this is true for functions that are fractions as well. Okay, so you're going to find all x that make gx equal to 0. Let's skip this for now. Whatever makes gx equal to 0, you set your domain as all real numbers and x does not equal whatever that value is. So this is saying that pretty much any value can be plugged in for x except for the one listed here. Let's try a couple of examples. This problem does not ask us to find domain. In this problem, we're just asked to carry out simple function operations, and they give us two functions here. Fx equals 3x minus 1 and gx equals x squared. So, when they give us a number, our first step is to just separate this so that it's f negative 2 equals and g negative 2 equals, and we're going to just solve these two functions separately. So first I will do 3 times negative 2 minus 1 equals negative 6 minus 1 equals negative 7. That's my really bad one. For G, where x equals negative 2, we're going to go ahead and instead of negative 2, we're going to write, or instead of x, sorry, we're going to write negative 2 squared. Negative 2 times negative 2 equals 4. Now that we've solved f and g separately, we can go back and see what the operation says to do. So we're going to do f plus g negative two equals, and we're going to add them together. So negative 7 plus 4 equals negative 3. In some instances, they might give you an operation and then just to ask you to solve it in terms of x. This means that your final answer will just be an expression and when they actually give you a number, your answer has to be a number. Alright, so let's look at what happens when we do g minus f in terms of x. So I'm going to go ahead and erase this. Okay, and we know that our answer is just going to be an expression. So I'm going to write g minus f x. This means they want us to put the g function first. So I'm going to rewrite the expression for gx in parentheses, minus, and then the expression for fx in parentheses. I have to put these in parentheses because this negative sign has to be distributed. So we end up with x squared minus 3x plus 1. In this situation, none of these can be combined because x squared is not the same thing as x. So we don't have to do anything else. This is our final expression. And this would be the answer if this was the question we were given. So there's two different ways that we can solve function operations. Either get a simplified expression or actually solve and get a number if given a number. Okay, so here's one more example where they're giving us a number. So if we are given a number, we know our answer has to be a number as well. Again, I'm going to go ahead and solve fx and gx separately, and then I'll go back and multiply at the end. So there we're replacing x with a 3 in this problem. So I have x squared minus 2. In place of x, I have to put a 3. So we get 3 squared minus 2 equals 3 times 3 is 9, minus 2 equals 7. And then we've got 6 divided by x, putting a 3 in place of x, so we get 6 divided by 3 equals 2. So here are my function values, and then we need to multiply them. So 7 times 2 equals 14. So this is the value for g times f, 3. So those are a few examples where they're actually asking you to solve an operation given. Here we're asked to find a domain. So we're not actually solving anything. We're not trying to find a simplified expression. We're just trying to find the domain. In this case, we're finding the domain of a division problem. So if I rewrite f divided by g x as fx divided by gx, we need to make sure that this value does not equal 0. Because when it equals 0, this function is not true. So if we plug in our expressions here, we get 3x squared minus 2 divided by 2x plus 6. And I need to go ahead and take this denominator and make sure that I know when it will equal 0. 0. So I'm going to do 2x plus 6 equals 0. Subtract 6 from both sides. 2x equals negative 6. And then divide both sides by 2. X equals negative 3. When x equals negative 3, this function is not true. So my domain is real numbers, and x does not equal negative 3. Because that's when this domain will equal 0. We can check our answer by going ahead and plugging 3 back in. Negative 3. Back in. 2 times negative 3 is negative 6 plus 6. Negative 6 plus 6 equals 0. So you can see that this would be 3x squared minus 2 over 0, which is not possible. Again, if we are ever using addition, subtraction, or multiplication, and one or both of the functions given have a fraction in them, then we need to also determine what values x cannot be for this domain. So I know my domain is going to be all real numbers, and x cannot equal, and I need to figure out what numbers it cannot equal. So again, I'm just going to go ahead and set each denominator equal to 0, because that's what values will not work in this set. And I get 3 equals, when I add x to both sides, 3 equals x. So I know x cannot equal 3, and x cannot equal, here we set x squared equal to 0. The square root of both of these means that x equals 0, so x cannot equal 0. So here's just kind of a wrap up. Whenever we're asked to solve, this star equals plus, minus, multiplication, or division. Okay, if we are asked to solve, we're going to split the functions when we're given a number, solve those, and then put back in the operation, and our final answer will have to be some form of a number. On the other hand, whenever we are given a variable here, not a number, we're just going to combine the given expressions using the operation given and simplify. Our final answer will be an expression. And wrap up when it comes to domains. This is the proper way to write it. If you write it like this, I will still accept it. Some function operations have no x doesn't equal. This is when there's no fractions and no division. Functions that are fractions can't have a denominator that is 0. And when we're dividing two functions, gx cannot equal 0. Because, in this case, gx equals the denominator. So really it's the same rule for both of these. Denominators can never equal 0. Remember that, and you have remembered the golden rule.